Alright guys, so for problem number 4, this is a truss problem. It says if the house's roof truss is loaded as shown, the forcing member DF is closest to what? Okay, so for those type of problem, first thing I would like to do is always determine the reaction force. So we have two reactions right here, AY and AX, and we have a LY right here. If you look at the graph, the only horizontal force in this case is AX. So that means that AX will be equal to 0 because there's nothing else to balance that out. So it means driving force in this case. And then to determine AY and LY, what I can do is that I can take a moment at A to determine what LY is, or take a moment at L to determine what A is. So what can I do in this case? Well, I can take a moment at A to determine what Ly is. Okay. Or you can take a moment at L to determine what A is. Because in this case, I know that I said that we have to take a moment at the support that with the most unknown, but in this case, AS is gone. We know that that's 0, so it means that this pin sport only have one reaction, and compared to this roller sport as one reaction, so you can take moment at either side. Okay. So summation moment at A, we have negative 1.6 multiplied by A feet. So this 0.8 kept that's gone because it's directly at A. Okay. And minus 1.6, 16 feet. Minus 1.6, 24 feet. Minus 1.6, 32 feet. Minus 1.6, 40 feet. Minus 0.8, 48 feet. And then plus Ly, 48. Okay, because all of those force is going in the clockwise direction to A. And since we assume that counterclockwise is positive, so clockwise must be negative. And Ly is going counterclockwise to A, so that's positive. Solve this equation for Ly. So we get Ly is equal to 4.8 kips. Okay, and right now we know that since they're symmetric, so if you cut it in the center, okay, all the forces on both sides are the same and their spacing is the same. So we know that. So we know that Ly will be equal to AY. Okay, since they're symmetric. Okay. Next thing is that since we only asked to determine the forcing member DF, so that means that we have to use method of section. So we have to cut at DF, okay, and then pick left or right side for analysis. Well, we always want to pick the side with the less unknowns to analysis. So since DF is kind of on the left side, so we want to use the left side for analysis. So let's draw this out. So this is my FDF. This is my 1.6 kips. This is my 1.6 kip. This is my 0.8 kips. This is my AY of 4.8 kips. And all of them a field spacing. Point C, this point E, they're going to point G. This point D, this is point B. Okay. Next thing, what we can do is that we want to take a moment at G. Why G? That's because that we know that FDF, since it's at an angle, that means that it will have a FDFX, FDFY and FDFX. If I zoom in, if you look at this graph right here, this is FD FX and this is FDFY. Okay. If you take a moment, FDFY is not it's not going to produce any moment at G. Okay, only FDX will do. So let's determine the height right now. So if we go back to this image right here, the total height 6 plus 4.5, that's 10.5. Okay, 10.5 feet. And then if we look at these drawings right here, so this is drawing 1, this is drawing 4, and then if you divide this thing into 3, so the height will be 10.5 divided by 3, so that would be 3.5. So each of this distance is 3.5 feet. Okay, so if we go back to here, let me erase this. We know that this horizontal distance, that's 8 feet, and then this distance right here, this 8 feet, this distance right here is 3.5 feet, right? So we're able to determine what's this distance right here. So by just doing the Pythagorean theorem, so we get this to be 8.73 feet. Okay. Right now, we can take a moment. Okay, so let's summation of moment at G equals 0. So take a moment at G, we get 4.8 multiplied by 24 plus 0.8 multiplied by 24 plus 1.6 multiplied by 16 plus 1.6 multiplied by 8 and minus FDFX, and we know that this would be FDF A over 8.73. Okay, and then we have to multiply that by what? Okay, let's see. So from F to G, the distance is 6 feet. So multiply by 6. That's the perpendicular distance. And then rearrange the equation to solve for FDF. We can get FDF is equal to negative 10.48 kips, which if we can write that as 10.48 kips compression. Okay. All right, guys, that's all for this problems. So for this kind of problems, always determine the reaction force is, even if it's unnecessary, but I would always like to determine the reaction force. So we just want to have a y action unknowns before we actually approach the problem, and then do a cut at whatever the questions ask you to forces at, and then most likely either do and then most likely you're going to take a moment. If not, you're just going to use the summation force in the x and y direction. Okay, so that's all for problem number 4. I'll see you guys in problem number 5. So problem number 5 says, for the shaded area shown, the surface area of solid obtained by rotating the area about the x-axis is closest to 1. So for this problems, we're asking to find the surface area. We know that the equation for surface area is equal to theta r L. In this case, theta is in radians. So, okay. So since this part is with contact to x, so that's not going to produce any surface area. So we have 3 surface area right here. So there's 1, 2, and 3. Okay. In this case, the r, which is the radius, is always this 45 millimeter. Okay. Why is that the case? Why don't we divide 45 by half? Because this entire object right here is in the positive x and positive y axis. So if we have another if we have its reflection right here, okay, then this this r won't be r, this will be diameter, okay. But this, since there's no reflection of this object, then that means that we have to take this, then that means that this 45 right here is the r. And then the L is basically just uh the length of the surface area. So for 1, this will be the length. For 2, this will be its length. And for 3, this will be its length. Okay, so let's write that. Oh, and another thing, angle theta. So this theta is in radians. So we know that if this thing is parallel to the x-axis, then that means that it has a 180 degree, like that. That means that it has 180 degrees. So if it's parallel, then we know the angle between them is going to be 180. So its theta is going to be 2 pi, right? But if it's perpendicular, then its theta is going to be just pi. Yeah. So for 1, area is equal to theta. So theta in this case will be pi. Multiply by the radius 45, and also multiply by this length right here. So this length right here will be square root of 27 squared plus 45 squared. And we're going to get 52.48. So multiply by 52.48. Okay, and then for 2, the area will be equal to 2 pi because it's parallel to the x-axis. Multiplied by 45, and then multiplied by the length. So this the length of this entire length right here. So that would be 27 plus 45. Area 3, that will be pi because that's perpendicular to the x. Multiplied by 45, and the length is also 45 in this case. Okay, so I have all those three. So the total area, basically, we just put all those in the calculator. We're gonna get the total area will be 34,138 millimeter squared. Okay, so that's the answer for this problem. I'll see you guys in problem number 6. Problem number 6 said a rope having a weight per unit length of 0.4 pound per feet is wound 2.5 times around a horizontal rod. Knowing that the coefficient of static friction between the rope and the rod is 0.3, the minimum length x of the rope that should be left hanging if 100-pound load is to be supported at the is to be supported is closest to what? So we are asking to determine the minimum length. Okay, so this is a belt friction problems. Okay, so we know that the equation for that is T1 over T2 equal to E mu beta. We know what beta we know what mu is 0.3, but we don't know what beta is. What beta is? We know that the beta is in radians, right? And we know that it's 1 to 2.5 times. Okay. Okay. If this is in radian, we know that if you wrap it 1 time, that's 2 pi, right? But if you wrap it 5 times, that means that you have to take that 2 pi multiplied by 2.5. So beta will be equal to 2 pi multiplied by 2.5 because it's 1 to 2.5 times. Every time you want it is 2 pi. That's beta. But we don't know what T1 and T2 is. Okay. Like I said, in this case, whichever one has a greater value is going to be T1. If you compare those two values, this thing right here is 0.4 multiplied by 10 plus this 100 pound. Comparing to this side is which is 0.4 multiplied by x. Clearly, we can see that the x has to be less than 10k. So we know that this must be T1. this must be T2. Okay, so T1 is equal to 0.4 multiplied by 10. Okay, that's the weight of this this rope right here, and then plus the weight of this object. So we get 104. And then for T2, that's just 0.4x. Okay, and then we're gonna plug everything into this equation. So we got T1, which is 104 over 0.4x equal to E raised to the mu beta, so 0.3 multiplied by this thing right here is 5 pi multiplied by 5 pi. Okay, right here, very easy. Rearrange the equation, solve for x. X will be equal to 104 or divided by e to the 0.3 multiplied by 5 pi over 0.4. Okay, so we get x will be equal to 2.33 feet. Okay, guys, so that's all for problem number 6. I'll see you guys in problem number 7. Okay, guys, so problem number 7 says the 4-meter wide open tank is handed at its bottom A and is held in place by a thin rod BC. The tank is filled with glycerin, whose density is 1263 kilogram per meter cube. After the tank is filled to a depth of 2.9 meter, the force T in the rod is closest to 1. Okay. So for fluid type of problem, I know you guys didn't get much into it, but for fluid type of problem, first thing we gotta do is that identify where's the free surface. So free surface is right here. Okay, so here's a free surface. So that means that in this case, we do nothing with B. Okay. So here's the free surface. And then let's write down all the equations. So for pressure, the equation is gamma Z, which is equal to rho GZ. And Z in this case is going to be the depth of the water, so which will be this D right here. Okay, because I know this total thing is 3 meters, but the water is only filled up to 2.9 meters. Okay, and then the force is going to be 1/2 of the rho G multiplied by the area, which rho GH multiplied by the area, which H in this case will be the Z. Okay, and then we know that pressure it increase with depth, so it's not going to be increased linearly. It's going to increase at depth. Oh, my bad. It's not going to increase uniformly. Okay, it's always going to increase with depth. So that's the pressure, and we know that if we treat this as a triangular load, then we know that its total load is going to be somewhere right here, which it will be at a 2/3 of 2.9 meter, and right here is the 1/3 is 2.9 meter. Okay, so like I said, since B is above the free surface, so we don't determine the pressure at B because it doesn't have any pressure. So at A, TA will be equal to rho GZ, which is the rho in this case, since this is not water, this is a glycerin. So that's 1263 multiplied by the gravity constant 9.81 and multiplied by the depth of the water, so which is 2.9. And we are going to get 3593 newtons. Okay. After we determine the pressure at A, we need to determine what's the weight. So the weight, since the width is given right here, 4 meter wide, so width is going to be B multiplied by T, so that's going to be 4 multiplied by 3593. We're going to get 1437.24 newtons. Okay. All right. Next thing we need to determine what's this force right here. Okay. So apply our equation. This force is going to be 1/2 of rho g z. Oh, my bad. Rho g. So we're going to 1/2 of the p multiplied by the area, which is 1/2 of 3593 multiplied by the area. So the area is going to be 4 multiplied by 2.9. I'm going to get F is equal to 208,399.8 newtons. Okay, so that's the F right here. But the question is asking to determine what a T is. So we have a T going in this direction, F going in this direction. Okay, and next thing what we can do is that we can take a moment. Okay, where can we take a moment at? We're going to take a moment at A. Okay, so when we take a moment at A, we're going to have this F going clockwise, so negative 208,399.8 multiplied by 1/3 of 2.9. Okay, my bad. We're not going to do 1/3 of 2.9 because when we take a moment of this thing, we're going to consider the distance like from where T is to where A is. So this one right here, this will be 1/3 of 3 meters. This will, oh, my bad. 2/3 of 3 meters. This will be 1/3 of 3 meters. Because T is with a distance of 3 meters from A. So we cannot just consider that as a 1/2. My bad. We cannot just consider 2.9 in this case. We'll have to consider this the entire distance between P and point A. So this is going to be 1/3 of 3. Then T is going counterclockwise to A, so plus T also by 3 equals 0. And then right now, we're just going to solve for tensional force T. So T will be equal to 69466.6, and then that's going to be equal to 69.47 kilonewtons. Okay. Hey guys, that's all for this problem. I'll see you guys in problem number 8. Okay, so for problem A, it says for the frame shown, the magnitude of the reaction force at pin C is closest to 1. Okay, we know we can see that C is a hinge, but I'm not sure if you guys are familiar with that concept of two force member. So C and B is a two force member. Okay, so C and B is two force member. So by two force member, I mean that whatever kind of shape it is, like it's either going to be this or this kind of shape. If it has two reactions right here, then it's going to be a two force member. So two force member total has 4 reactions. In this case, since B is a pin support, so it has 2 reactions, and C is a hinge, so it also has 2 reactions. Okay. So we can treat this as a two force member. Two force member CB. Okay, and then let's redraw this thing. This is FCB. This is 8 inch, 8 inch. This is 7 inch. This is 5 inch. Here's a 48-pound of load right here. Okay. What can we do at this point? Well, since we want to determine what FCB is, we can only take a moment at F right here because F is the only reaction right now because we consider FCB as a two force member, so that pin B is gone. So we can only take a moment at F right here. So initial moment at F. I got so FCB, you have to divide that into FCBY and FCBX. So, and also we need to determine those distance. So this is 16, and this is 5. Okay, and then do the Pythagorean theorem. Guess this is 16.76. Okay, so for FCBX, we have FCBX is going this direction to F, so it's going clockwise. So negative FCBX, that's going to be 16 over 16.76 multiplied by that perpendicular distance of 7-inch. Okay, and then FCBY is going like this to F. So minus FCB 5 over 16.76, and then multiplied by the perpendicular distance of right here to here, that's going to be 16-inch. Okay, and then we have this also this 48-pound loading, and it goes like this to F. So that's counterclockwise. So plus 48 multiplied by A equal to 0. Simplify this thing down. Again, negative FCB multiplied by 11.45 plus 384 equal to 0. And then solve everything in terms of FCB. Going to get FCB will be equal to 33.5 pounds. Okay, all right, guys. Oh, all right, guys. So that's all for problem number A, and that's all for our reviews. And I know the exam is on Tuesday, and I'll probably post the review session tonight. Yeah, guys, if you have any questions, please don't be hesitant to contact me. All right, good luck to you exam.